Your eyes might have spotted that ball before it hit you, but would you have noticed its color or just the motion? Peripheral vision is the ability to see outside our direct line of vision without needing to turn our eyes or head. It serves as our body's early warning system, alerting us to sudden movements, and is also part of how we experience the world. Think about how we are able to walk through a busy area, instinctively avoiding obstacles without focusing on them. But how much can our peripheral vision really do? While it's great at spotting motion, can it handle color just as well? So, let's start our experiment. To test this out, I used 3 differently colored shirts, pink, green, and black. Each participant sat still with their eyes focused on a center point marked out on the wall, while I walked along their right side, holding a t-shirt draped across my left shoulder. I marked the spot where they detected motion and again where they correctly identified the color with a piece of tape. Each test was repeated 6 times, twice for each color that was randomly selected to ensure accuracy. Lastly, I measured the angles at which the participants noticed movements and identified color, ensuring the consistency of the measurements by taking the readings at the bottom of each tape. This helped me compare their ability to detect motion versus color using their peripheral vision. The results were quite interesting. The participants consistently detected motion at wider angles, averaging around 86 degrees as compared to identifying colors, which averaged around 57 degrees. This simple experiment suggests that motion detection using our peripheral vision outperforms color recognition.
Why?
Let's first take a closer look at how our human eyes work. Our eyes rely on 2 types of photoreceptor cells in the retina, rods and cones. Rods are concentrated in the peripheral areas of the retina and are highly sensitive to light and motion. This makes them very effective at detecting changes in brightness and movement, even in low light conditions. However, rods don't perceive color. Cones, on the other hand, are responsible for color vision but are concentrated in the central part of the retina, called the fovea, but they do require more light to function effectively. This could explain why participants could detect motion at wider angles but struggled to identify color. This trait is rooted in evolution and isn't just limited to humans. Spotting movements in the environment, like a predator approaching, was far more critical to survival than identifying its color. Over time, our eyes adapted to prioritize motion detection in the periphery, ensuring faster reactions to potential dangers. These findings highlight the incredible design of our visual system. Even today, this trait remains vital. Peripheral vision helps us stay alert while driving, play sports and video games, or simply navigate crowded spaces without collisions. But there's still so much more to learn. Future studies could include investigating the effects of aging on peripheral vision and if certain eye exercises can actually improve it.